Hi everyone, so today we're going to be moving on from radicals and onto a new lesson of linear equations. So first, to start off, I'm going to be defining the basic definition of a linear equation. So what a linear equation is just an equation with the highest exponent being 1 and all real numbers. And when you graph it, it should turn into a line, as in a horizontal line, a vertical line, or any sort of line. Just a line with no curves. So there are multiple different forms of linear equations, and usually it's just any kind of equation with some kind of variable in it. But the main three forms that you're probably going to see throughout your math career is slope-intercept form, point-slope form, and standard form. So starting off with the most popular one, slope-intercept form, it looks something like this. So I'm just going to write it out here. Slope-intercept. So the form is y equals mx plus b. We'll be getting into what each variable stands for later on, but for today you just need to be able to be familiar with this form and know that this is the general form for slope-intercept. The next form is point-slope form. So that looks like y minus y1 equals m times x minus x1. And like I said, we'll be going into more about what the variables stand for later on. And then last but not least, we have standard form. So standard is ax plus by equals c. So this is what standard form looks like, and those are all three of the most common forms that you'll probably be using a lot later on. So first, I'm going to be reviewing a little bit about graphing. So we've never gotten into graphs in any of our previous lessons, so I'm just going to go over the basics. So a graph consists of two axes. So we have the x-axis and then the y-axis. So the vertical line right here, sorry, it's not straight, but that's the y-axis in red, and then in purple we have the x-axis, which is the horizontal line. And when you graph points, they're going to be in the form x comma y. And x is always before y, and same when you graph, you always find x before you find y. And a good way to remember that is that x is before y in the alphabet, so therefore it comes first when you're graphing also. So those are just the basic things you need to know about graphs, and always make sure that that all your lines are straight, and it's good to scale them on an appropriate level so that it matches whatever line you're graphing. Okay, so now that we went over what linear equations forms there are and what they generally look like and how it will look on a graph, to solving linear equations. So you've probably seen a lot of these types of equations that I'm about to give, but didn't recognize them as linear equations. So like I said before, they are linear because the exponent power is just 1, not more, not less, and it consists of variables that equal real numbers. So a basic example would be, 7x equals 4x minus 12. So this is a really simple equation, and as we've been doing with a bunch of other equations that we've gone over, you just solve for the variable. and this is considered a linear equation. So the first thing we do is subtract 4x on both sides to get the x on one side. So if you do minus 4x on both sides of the equal sign, you get 3x equals negative 12. And now we're going to solve for the variable. So we divide by 3 on both sides, or you can multiply by 1/3 on both sides. It's essentially doing the same thing. So if you divide 3x by 3, you get x, and divide negative 12 by 3, you get negative 4. So our answer is x equals negative 4 to this linear equation. Is 2a minus 3 equals 13. Now you probably don't see a lot of equations with variables other than x, which is because we're only in pre-algebra right now, but variables can be any sort of letter from the alphabet. It doesn't variable it is. But the reason why you usually say x or even y is because that's what we use to graph. Like I said before, there's an x-axis and a y-axis, and a point is x comma y. So that's the only reason why it's more common, but any sort of variable always works for a linear equation. So the first thing we do here is add 3 on both sides. So we get 2a equals 16, and to isolate the a completely, we have to divide by 2. So we get a equals 8. Next, we have 21 minus 2j equals 15. I'm just using all sorts of variables just so you guys can get familiar with the concept of using other variables besides the most common ones, which being x and y. So I see that the coefficient in front of the j is a negative. So you don't have to do this, but what I like to do is move it to the other side just because I want to make it positive. But it's fine if we work with negatives. It just makes it a lot easier for me to solve these kinds of equations. So with this, you get 21 equals plus 2j. And now we have to get the numbers on one side, so we subtract 15 on both sides, and 21 minus 15 equals 6. So we get 2j equals 6, or 6 equals 2j. They're the same thing, it doesn't matter what order it's in. And then divide by 2 on both sides to isolate the variable. You get j equals 3. And you can just kind of do that in your head. You don't necessarily have to write out all the steps. I'm just writing out the first few basic steps so that you know where I'm getting my numbers from. But after a while, you shouldn't have to write out those intermediate steps. So next, I have 3 plus 8, 15. So subtract 3 on both sides, you get 8x. 15 minus 3 is equal to 12. And then divide by 8, you get 12 over 8. And you can simplify this fraction even further because 12 and 8 are both divisible by 4. So 12 divided by 4 is equal to 3, and 8 divided by 4 is equal to 2. So we get 3/2 as our final answer. Let's try 9x plus 2 equals negative 11. So we're going to add 2 on both sides. Negative 11 plus 2 is negative 9, and negative 9 divided by 9 is equal to negative 1. I'm just trying to get through all the basic problems super fast so that we can get into the more complex ones. So next we have 2u plus 7 equals 21. So to get the numerical values on one side, we have to subtract by 7. 21 minus 7 is equal to 14. And divide by 2 to get 7 as your final answer. Okay, let's try an equation with some more numbers. So we have 8y plus 10 equals 3y plus 20. So the first thing I'm going to do, well, we know the goal is to get variables on one side and numbers on the other side. And I don't really want to work with negatives, so I'm going to move the 3y to the left so that the variable, the coefficient of the variable is positive. So 8y minus 3y is equal to 5y. You get 5y plus 10 is equal to 20. Now we're going to move the 10 over to the right, and you get 10. And then divide by 5 to ultimately get y equals 2. And like I said before, once you get used to this and get the hang of solving linear equations, you'll be able to do multiple steps in your head without writing anything down. So like, usually, to give an example, from here to here, I would skip right away from the first step to the third step, because you can just move the numbers and the variables at the same time. Now we have 14, we have 14 plus 2c equals 6c plus 5. So this time I'm going to be moving the numbers with the variables to the right instead of the left, because that way I can work with a positive number. So if you subtract 2c on both sides, you get 14 equals 6c minus 2c, which is 4c plus 5. And now I'm going to move the numerical values to the left, 14 minus 5. And then we're going to divide by 4 on both sides so that we can isolate the variable, and you get c equals 9 over 4. And I just kind of flop the equation around because I like having the variable that we're solving for on the left side in the end. So that's our final answer. Now let's do one with some distributive property. And hopefully you guys remember from our distributive property lesson how to do this. So we have 6 times 3k plus 5 equals 39. So the first thing I do before distribute. So like I said, parentheses basically assumes multiplication. So we know that we multiply 6 by 3k and add it to 6 times 5. So 6 times 3k would be 18k, because you just multiply the numbers in the front, and then we add that to 6 times 5, which is 30. So we get 18k plus 30 equals 39. And now we have to get all the numerical values on one side, so we get 18k equals 39 minus 30, which is just 9. And then we're going to divide by 18 to have the k isolated. So k is equal to 9 over 18. Now clearly this can be simplified because 9 and 18 are divisible by 9. So we get 9 divided by 9, which is 2. So our final answer is k equals 1/2. Let's try 2 times 3 minus a minus 6 equals negative 5a. So, as always, according to PEMDAS, we have to distribute first and get rid of the parentheses. So we get 2 times 3, which is 6, and then 2 times negative a, we get 2a. And then you copy down the rest of the equation. Now I'm going to combine like terms before moving anything around, just so we can work with less numbers. So on the left side, you see that there are two numerical values, so you can combine them. 6 minus 6 is 0, so that just completely gets rid of them. So you get 2a equals negative 5a. Now you see that there's only two more numbers left, if you want, what you want to call them, and there's no numerical values, so we just combine the variables on one side. So I'm going to move over the negative 5a to the left side to make the coefficient positive. So negative 2a plus 5a is equal to 3a, and that would equal 0 because there's nothing left on the other side. And if we divide by 3, you get a equals 0 over 3. Now when the numerator is equal to 0, that means it's just the number is just equal to 0. So we get a is equal to 0. On the other hand, if the denominator is equal to 0, that's undefined because you can't divide anything by 0. If you just think about it, in a real life situation, you can't split up a group into 0 groups. So we say that's just undefined. But if the numerator is 0, it's just simply equal to 0. Okay. Now let's try negative 2. Sorry. Okay. Let's try negative 2 parentheses 4 plus 3y is equal to negative 2, 4 plus y. So as always, we're going to use PEMDAS and distribute first. So you get minus 6y equals negative 8 minus 2y. So right off the bat, I noticed that the negative 6y is a pretty big negative, so which means if we move it to the right side, it'll turn into a bigger positive. So I'm going to add negative 6y to both sides to get negative 8 equals negative 8, and then you do negative 2y plus 6y, so which is 4y. And now we're going to move the negative 8 on the right side to the left side. So you do negative 8 plus 8, which is equal to 0. We have another 0 situation going on here. And then you divide by 4 on both sides, so 0 over 4, or y equals 0. Our next equation is 2 times 3l minus 2 plus 9 equals negative 5l. Now, just on a side note, the reason why I write my L's in a cursive way is because if you just write a normal L, like I just write it like that, it looks like a number 1, and you don't want to confuse your variables with numbers because that can really mess up the equation and get you a completely different answer. So make sure you're able to distinguish your variables from your numbers. And so if you use letters that look similar to numbers, make sure you know how to make them a little bit different. So I always use the cursive L for when I'm using the variable L. So let's get into problem. So we do distributive property. So we do 2 times 3l, which is 6l. And then 2 times negative 2, which is negative 4, plus 9 equals negative 5l. And now we're going to want to move the negative 5l to the left side so that we don't have to work with negatives. So 6l plus 5l is equal to 11l. And then we have negative 4 plus 9 equals 0. And I'm going to combine like terms so we have fewer numbers to work with. Negative 4 plus 9, or 9 minus 4, is 5, so we get 11l plus 5 equals 0. And then move the 5 to the other side to get 11l equals negative 5. Divide by 11 to get l equals negative 5 over 11. And this can't be simplified down any further because 5 and 11 are both prime numbers. Our next equation is a little simpler. We have 6s minus 5 equals negative 9s minus 9. And this is another situation with the variables looking kind of like numbers. I wrote s's like really small because they can look like 5s, or and you can even right now, if you look at the problem, these two kind of look similar. So make sure to make your s's smaller and a lot curvier so you know how to distinguish them. So going right into the problem, we're going to add 9s to both sides so that we don't have to work with negatives. So 6s plus 9s, which is equal to 15s. And make sure your 5's and s can be distinguished. And then copy down the rest of the problem. And then now we're going to move the numerical values to the other side. So we get 15s is equal to negative 9 plus negative 4. And now we have to divide by 15 on both sides in order to isolate s. So we get negative 4 over 15. And though 4 and 15 aren't prime numbers, they don't have any common factors, which means they can't be simplified down even further. So our final answer is s equals negative 4 over 15. Next up, we have negative 1 plus 3d equals negative 7 minus 60. And the first thing I'm going to do is move the negative 60 to the left side. So 3d plus 60 is equal to 90. And not 90 as the number, but 9d, the variable. Now we're going to move the negative 1 over to the right side, and we get negative 6. And then divide by 9, you get negative 6 over 9, and you are able to simplify this fraction this time because negative 6 and 9 are both divisible by 3. So we get 2 over 3. Next up, we have 2z equals 3z plus 1. Yet another example of being able to distinguish your variables and numbers. If you just write a z like this, it can look a lot like a 2, really pointy edges. So what I do is, as you can see in the problem, I put a slash through my z's to make sure that I know that the ones with slashes are z's and the ones without are 2's. So I'm going to subtract 2z on both sides so that I can move it over to the right. And you get 6 equals z plus 1. And then subtract 1 on both sides, or flip it around, z equals 5. And that's your final answer. Next up, we have negative 6 times 1 minus n equals 9 minus 2n. So distributive property, again, we distribute the negative 6 to get negative 6 plus 6n equals 9 minus 2n. And now we're going to move over the negative 2n to the left side to make it positive. So we get negative 6 plus 8n equals 9. Add 6 on both sides to get 8n equals 15. Divide by 8, you get 15 over 8. And that's your final answer. Our next problem is going to be a little bit shorter. It's 1/3 x plus 1 equals 7. So this time we're working with fractions. But the problem is a lot simpler, so it should be easy to solve. So the first thing we want to do is move the numerical values onto one side. So we get 7 minus 1, which is 6. And I mentioned this in the beginning of the video, but when you divide, if you have, like, for example, 4x, if you look down here, if you have 4x equals 16, and you divide by 4, that's essentially the same thing as multiplying by 1/4. So that's the same thing as this. Besides, you can't really go wrong with that. So it's the same thing. And now if you take a look at this problem, we have 1/3 x equals 6. So you can technically divide by, we are dividing by 1/3, but if you stack fractions on top of each other, it can look a little bit intimidating. So you probably learned this in school or math elsewhere, but dividing by a fraction is equal to multiplying it by its reciprocal. So we're going to multiply by 3/1, or just 3 on both sides. And that cancels out the coefficient of x. So we're left with 1x, or just x. And so we do 6 times 3/1, or 6 times 3, which is 18. So our answer is x equals 18. And we'll be practicing this even more in our next few lessons when we get into slopes. So we have a few more problems for linear equations. Let's do -2 minus 4c equals 7c minus 8. So I'm going to move the -4c to the right side, and you get 11c minus 8. Then move the -8 to get 6 equals 11c. Divide by 11 to ultimately get c equals 6. Oh, that's your final answer. Now, the reason why we're solving so many linear equations today that seem pretty simple enough is because I just want you guys to get used to what linear equations look like and how they might be solved, so that it's easier when we get into different forms of linear equations. I'm going to subtract 2y on both sides, get 3y plus 3 equals 15, and that's 3y equals 12. Divide by 3, and 12 divided by 3 is equal to 4, so you get y equals 4. By now you should be able to get the hang of it and do more steps in your head without writing them down. And our last problem for the day is going to be 3 times x plus 6 plus 2 equals 5x minus 4. First, we're going to distribute the 3 to get 3x plus 18 plus 2 equals 5x minus 4. And for this one, I'm going to do more than one step in the same problem, like I've been saying. So I'm going to add like terms on the left side while also moving over the 3x to the right side. So you get 18 plus 2, which is 20, and then 5x minus 3x, which is 2x minus 4. So if you do multiple steps in what you would usually do in one step, it's a lot easier and quicker and more efficient in getting the problem done. So now I'm going to flip the equation while also adding 4 on both sides. So you get 2x equals 24. And then divide by 2 on both sides, you get x equals 12, because 24 divided by 2 is equal to 12. And that's your final answer. So that was the last problem for today, and I hope you guys were able to familiarize yourself with what linear equations are and how to go about solving them.